So here's a question where at the end what we want to find is the correlation between homework and scores on an exam. And so we're given a joint density function with the constant c. So what we were going to do is we're going to walk through these 4 steps. We're going to first find c based on the properties of what a probability is, find the marginal and density functions, and then using those we're going to find the expected value of y and x, and then finally we'll find the correlation. So let's get started. So if we think the first step we want to be able to do is we know that if we look at a given joint density function with dx, dy, then if I add up all the individual probabilities, this should equal 1. Now let's bring that to our discrete single variate case. If we add up all of the probabilities of x, that should equal 1. So that's from the discrete case, and the similar thing applies here to the continuous case with 2 variables. So to do this, we would then integrate over the range of y, which is 0 to 1, the range of x, which is 0 to 2, of our f of x, y. So we have the constant 9/2 x y squared plus 1 dx dy. And this should equal 1. All right, so now we're going to use this to solve for c. So I'm going to bring c out of the function first. And so now I have the integral from 0 to 1. Now let's take the integral with respect to x. So I'll get 9/2 x squared y squared, and I bring that 2 down in front, plus x, and that's going to be evaluated between x equals 2 and x equals 0. And we still have the dy, and this is going to equal 1. So now as I evaluate this, I plug in 2 for x. So this is c times, I still have the integral of y, 9/4 times 2 squared, y squared, plus 2. That whole thing minus 9/4 0 squared, y squared, plus 0. Now, one thing to note is when the second x is 0 here, then because this is going to, if I add the 0, everything's going to go to 0. So that's going to be a quick shortcut we're going to look at going forward, is that second part will lead us to set it equal to 0. And so we still have the dy, and this is equal to 1. So now I'm left with c, the integral of 0 to 1. Now this is going to be 4. We'll cancel with that 4. And so I'll have 9y squared plus 2 dy is equal to 1. Now I integrate with respect to y. And so I get 9y cubed over 3 plus 2y evaluated when y is equal to 1 and y is equal to 0, and that equals 1. So I plug in the 1. So I get c times 3 times 1 cubed plus 2 times 1 is equal to 1. And at the 0 again, that's going to all cancel out to be zeros. So I get c times 3 plus 2 is 5 is equal to 1. So c is equal to 1/5. And so that is the c for our joint density function. So therefore, I can write f of xy is equal to 1/5 times 9/2 x y squared plus 1. And let's simplify that one more time. F of xy is equal to 9/10 x y squared plus 1/5 for x less than or equal to 2 and y less than or equal or between 0 and 1. So here we've found our joint density function. Now the next step is we can use this joint density function to find the marginal densities. So coming up, to find the marginal density, that is f sub x of x, is equal to the integral over the range of y of our joint density function dy. So that's the equation we're going to use. So to apply that, f sub x of x is equal to the integral, y goes from 0 to 1, of our joint density function, which was 9/10 xy squared plus 1/5 dy. So let's take the integral with respect to y. So I get 9/10 xy cubed, bring the 3 down below, plus 1/5 y, evaluated when y is equal to 1 and y is equal to 0. And so this is equal to, this will be 3, that will cancel out, and we're left with 3/10 x plus 1/5. So this is our marginal density of x, where x is going to be between 0 and 2. So there's our answer for the marginal distribution of x. I can do the same thing for y. So the marginal distribution of y is equal to the integral over x of f of xy dx. And so this is equal to the integral, x goes from 0 to 2, of 9/10 xy squared plus 1/5 dx. So this will be 9/10 x squared y squared, bring the 2 down below from the x squared, plus 1/5 x, evaluated when x is equal to 2 and x is equal to 0. And so that's what gives us our f sub y of y is equal to 9/5 y squared plus 2/5, where y is between 0 and 1. So there is our marginal density function for y. So now that we have that, we can go ahead and go to part 3, which is find the expected value of x and the variance of x. So the equation we're going to use is the expected value of x is equal to the integral over the range of x times the marginal density function of x dx. So applying that, we'll get x goes from 0 to 2 of x times 3/10 x plus 1/5 dx. So now we're going to take the integral. So we have 3/10 x squared. So that's going to be 3/10 x cubed. Bring the 3 down below. Plus we have 1/5 x. So that'll go to x squared. Bring the 2 down below. And it's evaluated when x is equal to 2 and x is equal to 0. So these 3's are going to cancel. And so we'll get 2 cubed, which is 8/10, plus 2 squared over 10, which is 4/10. And so this is equal to 12/10, or 6/5, or 1.2. And so that is the expected value of x. Now we can go to the next part, and that is to find the variance of x. This is equal to the expected value of x squared minus the quantity of x squared. Well, we just found this. This is 1.2, so we need to focus on this. Well, the expected value of x squared will follow that similar pattern. This is the integral of 0 to 2, now of x squared times the marginal density function of x, which is 3/10 x plus 1/5 dx. So we take the integral. So here we're going to get 3/10 x cubed. So this will be 3/10, the x cubed, I add 1 and bring the 4 down below, plus this will be 1/5 x squared. So this will be 1/5 x cubed, bring the 3 out in front, evaluated from 2 to 0. So as I plug that in, I should get 6/5 plus 8/15, which is equal to 26 over 15. And that's the expected value of x squared. And now I can use this as the variance of x is equal to 26 over 15 minus 6/5 squared. And this is equal to 22 over 75, or approximately 0.2933. I can find the standard deviation of x, which is just the square root of 0.2933. And so this will equal 0.5416. So here is the variance of x, and here's the standard deviation of x. So there's where we found, using the marginal density function of x, we found the expected value, and we found the variance and standard deviation. Now for y, we can do a similar thing. The expected value of y is equal to over the integral of y times f sub y of y. And in this case, what we found was this was 9/5 y squared plus 2/5 dy. And so if we work through this, what we'll find is the expected value of y will equal 0.65. We can then look at the variance of y is equal to the expected value of y squared minus expected value of y squared. And so when we solve for this, we get that the variance of y is equal to 0.0708, which makes the square root of that, the standard deviation of y, is equal to 0.2661. So there we have the variance of y and the standard deviation and the expected value of y. So that's parts 1, 2, and 3. Let's now go to part 4. And part 4 is we want to find the correlation between these. So let's go ahead and first write out the equation. So the correlation of x and y is equal to the covariance, which we write as xy, and divided by the standard deviation of x and the standard deviation of y. Well, we found this, and we found this, so this is the part that we need to find next. All right, so this is an important equation we're going to use. So how do I find the covariance of x and y? Well, the covariance of x and y is equal to the expected value of xy minus the expected value of x times the expected value of y. Well, as mentioned, we know these terms right here, so we just have to find this term right there. So the expected value of xy is going to equal the double integral from 0 to 1 and 0 to 2, y first, then x, of xy times the joint distribution, which in this case is 9/10 xy squared plus 1/5 dx dy. So let's write that more generically. So the expected value of xy is equal to the integral of y and x, xy, the joint distribution. So that's the equation we're going to apply. So let's go ahead and take or rewrite that integral. So this is going to equal 0 to 2, 0 to 1 of, now I'm going to multiply it through, so I'm going to get 9/10 x squared y cubed, and I get that from just multiplying this by that, and now we'll do the second term. Where we'll have plus 1/5 xy dy dx. Now it's a lot easier to take the integral. So I take the integral with respect to y first. So I'll get 9/10 x squared y to the fourth, bring the 4 out in front, plus 1/5 x y squared, bring the 2 out in front, evaluated from 1 to 0, and we still have our dx on the outside. So this is going to equal, when we get that all said and done, we'll get the integral from 0 to 2 of 9 over 40 x squared plus x over 10 dx. Now we take the integral of this, which we're going to get 940 x cubed, bring the 3 out in front, plus 1/10 x squared, bring the 2 out in front, evaluated from 2 to 0. And this will equal 4/5. And again, that is just the expected value of xy. Well, with that, now we can plug it back into here, or back into this equation right here. So we're going to get sigma xy is equal to the expected value of xy, which we found to be 4/5, minus the expected value of x, which we found to be 6/5, times the expected value of y, which we found to be 13/20. And that is going to equal 1 over 50, or 0.02. Well, now that we have that, now we can go back to our original equation that we really want to solve, and that's going to get us that the correlation between x and y is equal to 0.02, the covariance, divided by the standard deviation of x, which is 0.5416, times the standard deviation of y, which is 0.2661, and that is going to equal 0.1388. And that there is our final answer for the correlation between x and y, which means there's a positive correlation between study and exam score. And so again, looking at our big picture overall, we can take a density function, we can solve for c, we can find the marginal density functions, find the marginal expected, the expected values and the variance from the marginal densities, and then we can find the correlation between x and y.